Hello, my name is Samuel Herrera, and today I'm going to be introducing a mini lesson over the lapsing of time. And today we're going to be introducing that time elapsing, and we're going to approach that using the Make 60 approach, and we're going to solve a problem using linear and a set model. Okay, so the problem we have for today is this right here. Jack had a half day at school. Okay, he arrived at school at 7:45 a.m. Okay, and was released at 11:30 a.m. Okay, so now what we want to know, the question is, how much time elapsed from the time he arrived to the school until dismissal? Okay, so before we approach the problem, I just wanted to make notice of how difficult this topic is because yes, we are doing another, I guess, regrouping approach, just like we did with the Make 10 model. We're going to be doing the Make 60 model this time, but I guess since students aren't really, I guess, comfortable or familiar with things that aren't intervals of 10, I guess this is why sometimes it's a bit of a difficult concept for them to understand. Okay, so but first we'll go ahead and approach this using the Make 60. Okay. Okay, so basically, before we begin, the Make 60 is basically just trying to make 60. It's self-explanatory, okay? And since we're dealing with time, 60 is a big. I guess we have to put a big emphasis on it because it deals with both minutes. I'm sorry, with all three things: seconds, minutes, and hours. Although we don't really focus as much on seconds, it is something that the kids have to be familiar with. They have to understand that 60 seconds make a minute, 60 minutes make an hour. Okay. Okay, and basically what the Make 60 is, for example, I'll write it down on the whiteboard, is, for example, we had, let's say the time, um, 2:40, okay? And I'm not going to really put a big emphasis on the time of day, PM or AM, just as an example, okay? So basically what you're going to do for the Make 60 is, what you're going to try to do is basically how much it takes for you, okay? So you're going to add minutes to get you to the next or the closest hour, okay? So for example, if this one was 2:40, the closest following hour would be 3 o'clock, okay? So in order to make 60, okay, how much would I have to add? How many minutes would I have to add to make 60 to get to the nearest hour? Okay, so I would basically be adding 20, okay, and that would give me 60 minutes, okay? And as we explained before, something that we have to have the kids be familiar with is understanding that the 60 minutes is equal to 1 hour, okay? So again, another thing that kids have to be familiar with is the conversion of time. Okay, so if we understand that 60 minutes makes 1 hour, we already have two, and one more hour would make it 3 o'clock. Okay, so again, 60, we can just, minutes is equal to, okay, 1 hour. Okay, and that's just something that I feel that we should focus on before we do any of the approaches, whether it be the linear or the set model. Okay. Okay, and so we're gonna tackle the problem, and just something I think is something, it's a small tip I guess we can just do is just to have the students write down their start and their end time. Okay, so our start time would be 7:45. Okay, and our end time would be 11:30. Okay, so start would be 7:45 a.m. because it's in the morning, and then the end would be 11:30 a.m. as well. Okay. Okay. And we have that, and we're gonna go ahead and do the linear model. So all you're gonna do is basically linear. We've done. I'm pretty sure students are pretty familiar. So all you're gonna do like a number line. Okay. Okay. And at one end, on the left end, you're going to do your start time, and on the right end, you're going to do your end time. So 7:45 a.m., 11:30 a.m. Okay, so on the left, you have your, well, it was my left, but 7:45 here. Okay, start, end. Okay, and like we said, so our first step would be, okay, we're gonna go ahead and do our make 60. Okay, so same thing, 7:45, 45 minutes. How many more minutes would it take for me to get to the next hour? Okay, so if it's 7:45, it would take, okay, the kids need to understand the concept of skip counting as well. Okay, especially with time, it's going to be a lot of skip counting by 5s, 15s, and probably 30s. So having them understand that. So we understand that 15 more minutes would take us to 8. So we can do a dash. Okay, and I'll just put 8 a.m. Okay, and then I can do my skip count. Okay, and then I have to go ahead and, just so I don't forget, I'll go ahead and mark it on the top, put 15 minutes. And then after that, you would just basically skip count until you get to the closest hour of your end time, but not without going over. Okay, so we would keep going in increments of 1 hour. So 8, and then 9. Let me go ahead and spread them out a little bit more. 8, 9, do 10, and then we'll just do 11 right here. Okay, and remember, there's still an a.m. Okay, these are all in the morning. Okay, and now we're at 11, but our end time is at 11:30. Okay, remember, let's go ahead and put our increments. Okay, and remember, these are all 1 hour, and let's go ahead and put 1 hour, 1 hour, and then 1 hour. Okay, so you would do that there, and then after that, we have to understand how many minutes would it take. Because remember, we add 1 hour, it would be 12, so that'd be going over. So we stop at 11. Now we are here at 11, but we want to go all the way to 11:30. So we have to understand that 30 more minutes would give us 11:30. Okay, and then before we stop, we have to go ahead and add our times. Okay, and it's best to try to place an emphasis on, adding the minutes with the minutes and the hours with the hours. Okay, so then we will go ahead and do that. So 15 minutes and 30 minutes, you add those, which would give you 45 minutes, and then you add the hours. 1, 2, 3, 1, 2, 3. Okay, so then we understand that we have 3 hours, and then our time in minutes. Okay, and then our answer would be 3 hours and 45 minutes. Okay, and that's the linear approach. Okay, and now we're going to go ahead and do the set model. Okay, and then for that one, I felt that the easiest concept was actually just doing kind of like a T-chart. You know what, that's not the usual concept, but I felt like it helped out a lot. Okay, so on this side, we would just put, okay, this is what we're going to add. Okay, and this one deals more with the make 60. It has a lot more approach to it, and then this is the new time. Okay, so what we're doing, we know that it's 7:45 is our start time. So what we want to do next, okay, if 7:45 is our start time, again, how much will we add to get to the closest following hour? Okay, so we will do again. Our next time would be 15 minutes. Okay, so you're gonna add 15 minutes, and that would give you 8 a.m. Okay, and then again, you just keep adding in 1 hour increments until you get to the closest hour without going over. Okay, so 1 hour. Okay, and I'll keep going and do that just for the sake of time. Okay, so again, we stop at 11 a.m. Okay, and then we know, one more time, we're going to add minutes. Now we're going to regroup in order to make, with minutes, in order to make, well, we already made the 60, I'm sorry, so we're just adding minutes. We're no longer regrouping. Okay, so understand we stopped at 11, but our end time is 11:30, at 30 more minutes. Okay, and then that gives you your end time. Okay, and then once again, you would do the same thing. Okay, you would group your minutes with your minutes. 15 and 40 and 30, which would give you 45 minutes. And then you would add your hours together, which gave you 3 hours. 3 hours and 45 minutes. Okay? And that is how, those are two of several ways you can approach elapsed time. Okay, we did the linear model first, and then we did the set model. For the set model, we used sort of a t-chart to see the time we added, and then the new time we would get until we got to our end time. Okay, and then at the end we just added our elapsed time. Okay, so and yes, that's it for our elapsed time. Thank you.